In this video, I want to look at some examples of multiplying polynomials. We multiply polynomials by using the distributive property and laws of exponents. The distributive property just says a times b plus c equals ab plus ac. It means you distribute the multiplication term by term inside parentheses. And the laws of exponents come in when we multiply these monomial terms together. We have to combine exponents using the laws. Let's look at a couple of examples. If I want to simplify this expression, I need to carry out the multiplication first by distributing 2x squared times each of these terms, and also distributing negative 4x times each of these terms. Let's carry that out. 2x squared times 3x is 6x cubed. 2x squared times negative 6 is negative 12x squared. Here I have negative 4x times negative 2x, that's positive 8x squared, and negative 4x times 5, that's minus 20x. Finally, to simplify my answer, I'll combine like terms. These have the same variable part. It's negative 12x squared plus 8x squared. So as I write my final expression, I'll combine those to get negative 4x squared. Here is the final result of multiplying our expression above. It's really not more complicated when we're multiplying larger polynomials together. We just have to remember to apply the distributive property, which means that every term in the first polynomial will be multiplied by every term in the second polynomial. So we just have to make sure we're properly distributing. There's a couple of ways to show this. I could write this out using the distributive property. Multiply 3x minus 2 times 2x plus 5. I could start by applying the second binomial, 2x plus 5, to both of the first terms. Right? Every term in the first polynomial gets multiplied by the second polynomial. Then I distribute across parentheses. So 3x times 2x is 6x squared. 3x times 5 is plus 15x. Here I have minus 4x, and here I have minus 10. Then I look to combine like terms. Often there are like terms that can be combined in your final expression. Here I have 6x squared plus 15x minus 4x. That gives me plus 11x minus 10. So this is the final result. Notice that when we multiplied two binomials together, our final result was actually a trinomial. It had three terms because these middle terms combined together to give me the plus 11x. Here's a longer expression. We're multiplying a binomial times a trinomial. I could show it as I do above, just by expanding it term by term. I want to show you one other way that you can think about or visualize this multiplication. Sometimes this is called the box method for multiplying, and we might see it later with factoring. I take one polynomial and write it across the top, a squared minus 3a plus 7. I take the other one and write it down the side, a plus 2. And this is just a visual way of making sure that every term gets multiplied by every term within the polynomials. So wherever there's a cross section here, I'll multiply those terms. Here I have a times a squared, that's a cubed. Here I have a times negative 3a, that's minus 3a squared. Here I have a times 7, that's 7a. Here I have 2a squared. In this box I have minus 6a. And finally, in this box I have positive 14. So every time I'm just multiplying the amount at the end of the row and column. Now I look at this result and I try to combine like terms as I write my final expression. So I start with the largest term with largest degree, a cubed. Then I have minus 3a squared plus 2a squared. So that gives me minus a squared as I combine those. I also have negative 6a plus 7a, so I'll combine those. That gives me positive a, and finally I have a positive 14, so we write that as plus 14. Here's our final simplified result. We would get the same amount if we would have multiplied this by expanding the terms and applying the distributive property. This is just a visual way of showing what is going on with the distributive property.